The Dominion Astrophysical Observatory in Victoria has been a place of public engagement and public education for over 100 years, and there are no signs that this is going to slow down in the future. Because people are still interested today and are still coming, and the reasons that they're interested stand the test of time. Because even when this was being built, it was considered a marvel of modern engineering. And when you talk about the engineering, the reasons behind the development of this telescope, and the science that's being done with it now, it's hard not to be interested today. They actually figured that a telescope in Victoria would have been able to accomplish the work of one up to 118 inches in aperture, or in the size of the mirror. And that was important because the largest telescope in the world till the late 1940s was only 100 inches. The technology didn't exist to build a better telescope in Canada on Canadian soil than you could build here in Victoria. And so when the telescope was proposed, it was not only pitched to politicians around it being an instrument of science, but also a statement of the maturity and modernity of the Canadian state. The telescope would have been not just a symbol or a tool for astronomers, but a symbol for Canada taking that role on the world stage. The most difficult element of constructing the telescope was, of course, getting a road up the side of this mountain. All of the material had to be carried up what could only be called a wagon road. It took many horse teams. The heaviest single piece, I believe, that came up the hill was a polar axis at over 12 tons. When you look at the level of work required, it took almost 2 years of hard manual labor. All of the concrete for the big pier behind me was poured on site in 1915. A lot of this material was swung through the front of the building using the ribbing of the dome above me, so it was very rudimentary. They had to use what was available on site that had to be done very carefully in a calculating way. The first director and designer of the telescope was John Stanley Plaskett. Plaskett's an interesting individual because he didn't come to astronomy young. He was born in the 1860s. He grew up on an Ontario farm, and from there he developed an interest in engineering. But while he was doing that, he was also taking night courses in physics. And in 1903, he was hired on to the staff for the yet-to-be-completed Dominion Observatory in Ottawa. And from there, he really led the fledgling astrophysics program, where they really took the first major strides of cementing Canada's place as leaders in the field of astrophysics as a whole.
It's very interesting working in a historic place like this. I mean, every night I come in and I think of Plaskett and people 100 years ago. The biggest discovery that actually took many years to develop, performed by Plaskett and his colleagues, was measuring the velocities of very bright, massive stars in the Milky Way. And they use those velocities basically to gauge the size of the Milky Way and sketch a map of the Milky Way. It was really the first accurate picture of the actual size of the Milky Way galaxy itself. It certainly gave you a good perspective of where we stood, man stood in the universe, where the Earth stood, and it certainly reduced the significance, I guess, of the planet according to the rest of the universe. And it was not too long after that when it was discovered at other facilities that the Milky Way was really just one of many external galaxies as well. So one of the most interesting things I found was that right from the very first day that the telescope was commissioned and saw first light, the public were involved. There were open houses starting right from day one. So the public was always welcome. I think it was Saturday nights, just like it is now, to come up and see what their tax money was paying for.
I think the most fascinating thing is that it's 100 years later, it's still now a pretty productive instrument. There are technologies from somewhat different eras on the telescope that work together and produce scientifically valuable data. So when you combine some 50 years old mechanical parts with some newer modern electronics, and you want them to actually listen to each other and talk to each other and do things properly, that's a big challenge. We want to automate this telescope so that many more scientists will be able to use it. Traveling to Victoria, it can be quite costly, especially come here and you don't see any clear skies. So an automated telescope is a great way to tackle that. We have lots of experience automating telescopes. We have an automated telescope up on the hill here. And now we're going to use that experience to automate the Plaskett telescope. It's proven to be more challenging, but we are quite dedicated. When I'm here, sometimes I almost have flashbacks. I'm thinking what it looked like being here 100 years ago, when they did not have lots of things that we are so accustomed to today. So just thinking, okay, how did they put this thing here? How did they assemble that thing over there? How did they walk around here? What did they do? How they did that? So the times were quite different. And there are imprints from those times in various things around here. So you look at the rail that supports the moving part of the dome, for example, and on that rail, it repeatedly says 1916, 1916. So that metal was forged in 1916. And you think, wow, it's still in great shape. So there's lots of history, and you think that particular ladder, people were using it, were sitting on it 100 years ago and hoping to find out what we see up in the sky there. And we still kind of ask ourselves the same or similar questions.
The telescope was a part of the civic identity of the city. It mattered to more than just the astronomers here or the people who came to visit. It was a window into what the future might look like. The detail that went into the engineering, the design here, it stood to the test of time. The entire structure of what the universe looked like was changing almost overnight because of the capacity for astrophysics to provide answers that just hadn't been possible prior to that. At a fundamental level, this is discovering what the universe looks like. And how can you not get excited about pulling in light from an object 30 million light years away that would have been leaving that target right between the transition of dinosaurs and now, and getting an understanding of what's going on, what was going on. Imaging in the night sky, looking back, looking through a telescope is looking back in time. And so when we all get a chance to look back and reflect on where we've come from and the choices and difficult decisions that have all led to here, how can you not be excited?